Hello and welcome to BYJU'S Exam Prep IAS. In today's session of Big News, we shall be talking about the return of El Nino as a phenomena after 7 long years. Now, El Nino is an event that you oftentimes hear and read about in newspaper headlines whenever you have an issue or the news relating to monsoonal rainfall, etc. But El Nino is a phenomena which does occur in the Pacific Ocean and has got an impact across the globe. From the deadly outbreak of dengue, which is being experienced in Peruvian coastline as of now, to increased cyclonic formations in the region of Pacific, to drier conditions in the region of Australia and reduced rainfall in India, the impact of El Nino is truly global. So in this video, we shall try to understand what this El Nino is. Why does it come into existence? And more particularly so, how do we get to know that when an El Nino condition is going to come across, and also the impact that it will have across Indian monsoon. Now, El Nino condition or the functionality of El Nino is something which was incidentally discovered by the Peruvian fishermen long time back. And they have known it for many years. Basically, at one point of time, they were surprised by the presence of, in fact, the warmer waters on the Peruvian coastline. Because otherwise, on the coastline of Peru, due to the cold ocean currents, you have colder waters which are present. And also, that would mean increased amount of fish supply in general. Now, the Peruvian coastline and the fishermen in that region, they observed that sometimes, that is in certain years, they would observe suddenly the waters would become warmer. And that would be associated with increased rainfall, but at the same time, it would be associated with decreased fish supply. And because this was an event generally experienced during the Christmas time, that is in the northern winters, that is why it was named as El Nino. So the literal meaning of El Nino in Spanish, it turns out to be the Christ child or the little child. So let us understand what are the phases of El Nino and how they are created. So first of all, El Nino is a part of the larger circulation and the larger atmospheric circulation initiated because of the difference in sea surface temperature in the eastern and western Pacific. And that entire atmospheric circulation along with the difference in temperature across the ocean, that is regarded as El Niño Southern Oscillation or ENSO in short. Now, El Nino Southern Oscillation is what? It is basically a recurring climate pattern involving changes in the temperature of waters in the central and eastern tropical Pacific Ocean. Now, when we say oscillation, whenever you hear the term oscillation means what? That the conditions tend to repeat themselves. In a fixed pattern, the conditions will repeat themselves. Now, in the case of the Pacific Ocean as well, because the Pacific Ocean is very large around the region of southern part of equator. So you have differential heating which is created in different parts of the Pacific Ocean. Why? We'll take a look at it very shortly. But then you have conditions where sometimes the western portion of Pacific gets heated up, sometimes the central and the eastern portion of the Pacific gets heated up. So that brings about different types of atmospheric circulation. So in this case of oscillation that we talk about, the conditions, they basically keep on changing from the conditions of El Nino, where you have warmer waters or referred to as the warming phase of the Pacific. You have the conditions of La Nina, where you have the colder waters or in general the cooling of the central and the eastern Pacific is observed. And then you also have the neutral condition, which is prevalent otherwise. So here you'll find that the conditions, the atmospheric conditions, they keep on oscillating between these three phases. That is either it will be an El Nino condition, La Nina condition, or a neutral condition. Now, before understanding the phase of El Nino, it is important for us to understand what do we experience during neutral conditions. And for that, we take a brief look at Walker circulation. What is Walker circulation and what is experienced in the equatorial Pacific? So here, when we talk about the region of equatorial Pacific, and more particularly so the southern part of equatorial Pacific, let's assume that this is the rough equator. Let us assume here. Now, around the region of equator, we find the movement of permanent wind system. And around the region of equator, the permanent wind system which is prominent is the trade winds. In general, what is the direction that the trade winds follow? In the northern hemisphere, they will follow a direction of northeast to southwest, and in the southern hemisphere, southeast to northwest. So in general, these trade winds, as they move across this vast oceanic region, they will end up pushing the surface water, which is warmer, in the general direction of westward motion. So that is where the waters, they get pushed towards the western portion of the Pacific, and all of them being the surface water. And please understand, when we talk about any equatorial region or tropical waters of the ocean, always keep one thing in mind, that the surface water is going to be the warmest of them. Why? Because the primary source of heat is solar insolation, and solar insolation will be maximum at the surface of the water. So when the surface water is being dragged away by the trade winds, we can say that all this warm water is being dragged away, and as a result of this, the warm water accumulates in the region of western Pacific. And these warm waters, when they accumulate, they provide a kind of a height gradient. That accumulated water forms a height gradient of close to around 8 to 10 centimeter as compared to the normal sea level. And that height is maintained by the continuous motion of these trade winds. They keep the water accumulated in the western Pacific. But nonetheless, when you have the warm waters reaching the region of western Pacific, that creates a condition of low pressure. Obviously, warmer waters will create a thermal low pressure in that region. And low pressure means winds will be attracted towards that low pressure. From all direction, winds will be attracted towards that low pressure with significant force. The trade winds, they become much more stronger because now their destination is that activated low pressure. The winds, they will reach here in the region of the low pressure, and then they will start rising up after getting heated up. And here they will form clouds, convective clouds in large proportion, and that will cause heavy rainfall in the region around Indonesia, Philippines, northern portion of Australia, and so on. Now further after that, the air still rises up and then diverges. One part goes towards the region of Indian Ocean, the other portion reaches the area of Central and Eastern Pacific, and that is where the air sinks in the region of the otherwise high pressure which is prevalent. So in that entire area, you have high pressure. And there is another reason for the high pressure being present in the Central and Eastern Pacific. And what is the reason? It is very simple. So think about the ocean water under normal circumstance. Now, the surface will be very hot, isn't it? The surface temperature will be very high. The surface in general will be very, very hot. Now, as a result of that, the subsurface water will be slightly cooler water. Now, as the trade winds are moving over the surface, the trade winds will be able to carry this surface water along with them, the warm water. Now, when the surface water is dragged away, means what? The subsurface water, which is colder, that rises up to the above surface. So that means that in this region, you experience upwelling, due to which the surface temperature reduces. So in this area, you have the upwelling event whereby the subsurface water rises up, and due to this upwelling, you have a reduction in surface temperature. Sea surface temperature reduces, and as a consequence of that, you already have the creation of high pressure. Now, whenever upwelling as an event occurs, What is the consequence of that? You will have increased phytoplanktons and their growth, which will be very profound, and naturally the fish population will expand. So these areas are very good for fisheries in general. So this is something which prevails during the normal conditions. Under natural circumstances, this is a circulation, atmospheric circulation, which is initiated due to the surface properties of the Pacific Ocean. Now this was for the first time discovered by Sir Gilbert Walker. And that is why this circulation, this atmospheric circulation that we see, this atmospheric circulation of winds blowing towards the region of Eastern Pacific, rising up, and then thereby sinking in other area, Western Pacific, sinking in Eastern, and vice versa. That is what is referred to as the Walker cell or the Walker circulation. So in the normal Walker circulation, what happens? If you have to arrange your chain of thoughts, winds will drag the surface water in the Western Pacific, where there will be piling up of water. Low pressure will be created that will attract more winds. Winds will rise up, form the clouds, bring rainfall in the region of Australia, Indonesia, Philippines, and colder waters which have been exposed from subsurface in the region of Central and Eastern Pacific, that will create a relative high pressure, inducing a cell of circulation, that is the Walker cell. So this Walker cell, which is naturally found, it will have its impact in the other regions as well. It is not something restricted only in the Pacific Ocean. If you observe the overall impact, observe that this circulation has got a profound impact even in the case of Indian Ocean, particularly the southern and western part of Indian Ocean. Because observe, this is your Pacific Walker circulation under the neutral conditions, and the winds, as they are blowing, they will rise up. Here the winds will diverge. Here they are sinking, and that will create high pressure condition in the region of the central and also southern portion of Indian Ocean. Now, once we have understood the normal circulation, now let us understand what happens during El Nino event. But before directly jumping into El Nino event, think about one basic phenomena that you would have observed in your household as well. So think about, let's say, you have a jar of water. A jar, let's suppose, which is full of water, right, to the brim. Now on one side of that jar, you put a fan, let's suppose, which is blowing wind and air in this direction. Now what you will observe is, under general circumstances, that due to that wind which is blowing, water keeps on accumulating in this area. Some water might even spill over, and water keeps on accumulating here. But then, do one thing. Switch off the fan and remove the fan. So the air which is blowing, that also disappears. Now, will the water stay accumulated where it was, or will the water indicate a difference? The water actually, in the lack of wind, that will initiate a kind of a flow back. It will flow back to its natural position. Now, why have we talked about this particular example? That is because something very similar is observed when we talk about the conditions of El Nino. So, under normal circulation of Walker cell, we observe that all that warm water is piled up in the region of the Western Pacific due to the continuous movement of the trade winds. And it is the trade winds which keep that water accumulated. Now, every 2 to 3 years or 3 to 4 years, you come across an event or a situation where these trade winds, they become very, very weak. And in certain cases, they become even absent. So as a result of that, what happens? All that warm water which was, let's say, accumulated in the region of the Western Pacific, let's assume the warm water accumulated in the Western Pacific. Now you don't have the trade winds to support that accumulation anymore. It is similar to removing that fan. Then what will happen? All this accumulated water will initiate a flow back. It will start flowing back and it will accumulate in the Central and Eastern Pacific. Now, rather than the Western Pacific, warm waters have accumulated in the Central and Eastern Pacific. And that means now the air circulation will be the absolute reverse of what we observed under the condition of normal Walker cell. Because now in the Eastern Pacific, air and winds will be attracted. Those winds will rise up, form convective clouds, brings very heavy rainfall in the region of South American coastline, Peruvian coast, etc. And then furthermore, it will diverge and it will sink in the western part of the Pacific. So in a way, it is a reversal of the Walker cell that we talked about. And this condition is referred to as El Nino. Now this condition is created why? Because the trade winds have weakened. And why do the trade winds weaken? The trade winds, they start to weaken because of heating of the Pacific Ocean. Because please understand, even these trade winds, they are generated from where? What is the source of trade winds? So trade winds are generated from a high pressure, that is subtropical high pressure zone. Now this high pressure, this region, if it starts getting heated, the high pressure weakens. So heating weakens the high pressure. And when the high pressure in itself is weakened, so the winds which are originating because of that high pressure, that will almost become absent, if not very irregular. So due to this, trade winds weaken, become absent. And when the trade winds become absent, there is a flow back of warm water. And this flow back of warm water means these warmer waters accumulate in the Central and Eastern Pacific. Warmer waters accumulate in Central and Eastern Pacific. And this is the condition of El Nino. Now, El Nino as a phenomena is referred to as the warming phase of the Pacific Ocean, because in the image also you would observe that how during the conditions of El Nino, observe here, take a look at the image here, observe how in the Pacific Ocean, the central and the eastern portion of the Pacific, that gets particularly hot. So that is where incredible low pressure is developed that will shift the wind direction towards that low pressure. And that means upwelling will happen in this area. This will be the region which will get converted into a high pressure because of colder temperature. Now, how do we get to know if an year is being declared as an El Nino year or whether we are going to experience La Nina conditions? How do we get to know that? So that is something which is deciphered with the following or the study of what is referred to as ONI or Oceanic Nino Index. Now, Oceanic Nino Index, it basically ends up measuring the sea surface temperature anomaly, that whether the sea surface temperature is higher than average or lower than average. If the sea surface temperature in central and eastern part of the Pacific, if the sea surface temperature gets higher than 0.5 degrees Celsius as compared to the average, it can create El Nino conditions. If the sea surface temperature on an average is lower than 0.5 degrees Celsius as compared to the average temperature, it can create La Nina conditions. So if, for example, when we talk about ONI, it tracks the running 3-month average sea surface temperature in the east central tropical Pacific between 120 degree to 170 degree west, around the region of international dateline, and whether they are warmer or colder than average. So if it is higher, the temperature is higher as compared to average by more than 0.5 degrees Celsius, that condition can lead to El Nino. Right? So observe this chart here. So this tells you about the Nino index. So observe how around the year 2016, we had the conditions of severe El Nino. And for the past 3 years, we have been experiencing conditions of La Nina, which is a very rare phenomena that you consider La Nina phenomena and you experience it for 3 consecutive years. This is also what was referred to as the triple dip La Nina. And this year, what is the condition in this particular year? If you observe the conditions this year, this is the present and the latest condition that you will observe between 14th May to 10th of June. You will observe that the sea surface temperature anomaly in the western part and the eastern part of the Pacific, they indicate a rise in temperature. Particularly in the eastern part, you will observe that the temperature is increasing as much as 2 to 3 degrees Celsius as compared to the average. So because there is warming, there will be a kind of a El Nino phenomena which is being experienced. And this strengthens when? This becomes very strong in the southern hemisphere's summer season. That is when the heating of the southern hemisphere will happen. So that is why in the northern winters and the southern summers, that is typically in the month of November, December, January, that is when it becomes very, very strong. So the El Nino phenomena that we are going to experience this year, it is going to build up from the month of August onwards, getting stronger by the time that we reach 2024. So the later part of 23 and the year of 24, we are going to experience stronger El Nino conditions following that year. Now, what is the impact on monsoon? So just like the case of the normal Walker circulation, the circulation initiated by El Nino will also have wide-ranging impact on the monsoonal circulations and circulations in the Indian Ocean. Observe how during the conditions of El Nino, the circulation which is initiated due to warmer waters in central and eastern Pacific, here you have the rising air column, it diverges, and due to the circulation, observe here also, you have a rising air column. So what it does is, it decreases the high pressure condition present or weakens the high pressure condition present in the western part of Indian Ocean and southwestern part of Indian Ocean. But why is that southwestern part of Indian Ocean so important? Because that southwestern part of Indian Ocean, particularly this area around the Mascarene Islands, this is the high pressure region, which is also referred to as Mascarene High. Now this Mascarene High, it is a subtropical high pressure zone, and from here the trade winds which are generated, they end up crossing the equator, and after crossing the equator, due to the Coriolis force, they will bend to the right in the northern hemisphere and they will hit the Indian coastline. So the strength of the Mascarene high pressure becomes very important for the strength of the monsoon, because stronger the Mascarene high, more winds will be driven towards the Indian subcontinent. That would mean more rainfall received by India. And we have seen that as per the circulation initiated by El Nino, you have the weakening of the high pressure because here you have a rising air column. So that Mascarene high, when it gets weaker, means what? Means lesser winds originating from that high pressure. Means what? Lesser moist winds coming to India, and that implies lesser rainfall experienced by India. So that is something where it will impact the Indian monsoon. So weakening of Mascarene high, it weakens, means lesser winds, means less rainfall in India. Now, what is the impact of this that we are going to experience? What is the predicted outcome? So already we are experiencing a less amount of rainfall across the country. The onset of monsoon has been delayed and the coverage of the monsoon is even further delayed. Why? Because throughout the months of April and May, different portions of the northern part of the country have been receiving rainfall. So we did not have the development of acute low pressure cells, convective cells across the country which would attract the winds and bring rainfall. So automatically the monsoonal winds are weak. And this El Nino phenomena, it is expected to get stronger from August onwards. So that is when the mascarene high will be weakened. So from August onwards, we are going to experience much lesser amount of rainfall and much weaker monsoon phenomena. August, September are expected to be very, very dry. And then this El Nino will strengthen further during the winter months, and 2024 is when we are expecting the full wrath of that El Nino, where we are again going to experience a decreased rainfall. Now, India is a country where close to around 70 to 75% of the annual rain is experienced only during the monsoon season. This year, already the onset has been disturbed because of cyclonic events and otherwise also. And if these El Nino conditions further delay and weaken the amount of rainfall, we are staring at crop failures and agricultural crisis in general. So that is all that you need to know about the feature of El Nino. In this session, we have talked about what do we understand by the enso circulation, what is a Walker cell, what is the impact in various parts of the globe. So in El Nino, we have seen that you have increased rainfall occurring across the Peruvian coastline. That is why the Peruvian coastline is experiencing a record outbreak of dengue as a disease also. And that will have an overarching impact in the Indian Ocean by weakening the mascarene high. It will weaken the Indian monsoon as well. So that is something which is relevant both for your prelims as well as for your mains exam. Thank you.